All right, so I'm going to talk today about self-correction in science and its connection to open science and where we've come and where I think we maybe should focus our efforts going forward. And I'm looking forward to having some discussion with you all about this at the end. But feel free to jump in if you have a question. I'll try to notice that. I want to start by acknowledging my collaborators, and these are people with whom I've worked and written papers and so on. Any mistakes in the talk are mine, any bad opinions are mine, but a lot of my thinking has been informed by these people. So I have been working on open science, and more generally, I would say the kind of reform movement in psychology and more in other fields, not just psychology. And one of the questions that really kind of comes up for me, both in my research, but also in my teaching, when I teach about psychology as a science, I teach research methods, for example, we talk about what is the difference between science and pseudoscience, is this question of what makes something scientific, what makes psychology scientific, what makes any discipline a scientific discipline. And I think this becomes a very difficult question. I used to teach what the textbooks in my field say, which is that there's a scientific method, but now I understand that that's not a really good answer to this question. There are some methods that are very typical of science, but there's no single method that's unique to science or that's a guarantee that things will be scientific. And so instead, I've been coming more to this realization that what makes science scientific is complicated and messy and not a simple answer. And this is interestingly reflected even in public opinion about science. So this is data from the US, from a representative sample published by Pew, where they survey, every few years, they survey a representative sample of Americans. And one of the things they ask is about trust in different institutions. How much do you trust scientists? How much do you trust politicians, military, things like that? And so these green bars are the results for the proportion of respondents who say that they have a good deal or a great deal of trust in science and scientists, the green bars. And you can see that that's consistently high. I think the latest data, more recent than this, are still pretty high, even after COVID and everything that's happened with that. And as high or higher than almost any other group. And this is not just the US. Pew also has data from around the world. So public trust in science and scientists is quite high. But what's really interesting to me is in the same survey, they also ask respondents questions about, do they agree that scientists, for example, provide fair and accurate information, are transparent about conflicts of interest, or my favorite one, admit and take responsibility for mistakes. And the green dots are the proportions of respondents who agree with these statements for scientists in different disciplines. And you can see that it's pretty low, that most people do not agree that scientists admit and take responsibility for mistakes. And I wouldn't agree either, right? Scientists are humans. Humans famously do not admit and take responsibility for mistakes. So it's not necessarily a derogation of scientists to say that they don't do this. And what's interesting is that this doesn't seem to prevent the public from having trust in science. So science can be trustworthy, at least in the public's eyes, even if individual scientists don't admit and take responsibility for mistakes. And this actually echoes what I think a lot of philosophers of science have come to believe about trust in science, which is that it's really not about individual scientists being trustworthy. It's about a social process within the scientific community. And this was articulated by a psychologist in the 80s, Don Campbell, who wrote, the dependability of scientific reports comes from a social process rather than from dependence upon the honesty and competence of any single experimenter. Organized distrust produces trustworthy reports. So there's something about the organization of science that leads to a social process that helps us admit and take responsibility for our mistakes, even though individually we might not be very good at it. And this is also consistent with some sociology of science. For example, Robert Merton in the 50s talked about different norms in science, and he articulated 4 important norms that he thought were characteristic of scientific kind of social processes. And these included things like communality, which used to be called communism, then changed its name, which is probably the closest to open science, but also things like universalism, which is the idea that the validity of the scientific claim doesn't depend on who's making it, their status, whether they're a professor or a student or unaffiliated with an academic institution at all, or their prestige or anything else. Obviously, status matters a lot in other aspects of science, but when evaluating the validity of a claim, then status and other identities of the person making the claim shouldn't matter. Disinterestedness is a controversial one. Not everybody agrees that this is a core value of science, that some people argue that science can work even if individual scientists are self-interested, but this was one that Merton advocated for. And then the last one is what he calls organized distrust or organized skepticism. This is what Don Campbell was referring to, which is that we don't say that anything is sacred. There's nothing that you're not allowed to question or challenge. It's always okay to ask, let me see your work, let me see how you got there. So obviously it's related to openness and communality, but it's a distinct idea that we are encouraged to critique each other, to doubt each other, and to ask for verification. So I'm going to talk a lot about organized distrust today and its role specifically in scientific self-correction. And so I think that what makes science trustworthy is really, to some extent, all of the norms, and especially the communality, openness norm, universalism, and organized distrust. But this last step, organized distrust, is really key to making science self-correcting. And so one of the things we often hear repeated is this idea that science is self-correcting. And it's something that I used to say when I taught undergraduate research methods, but now I'm a little bit more careful with this. I say that we strive to be self-correcting, but I think it's a really important question. How do we know that we are self-correcting? What does it mean? We can't just say that we're self-correcting and that makes us self-correcting. And I was really eager to try to find answers to this question of like, how do we know that a scientific field is self-correcting? Where is the evidence? And there's a historian of science, Naomi Oreskes, who's written some really good work on trust in science. She has a great TED Talk, one of the few TED Talks I've watched, and I really recommend it, about what makes science trustworthy. And recently she published a new book where it was called Why Trust Science. And in it, I really like a lot of her writing, but there was one kind of promise that I was hoping the book would fulfill, which was to tell me what makes science self-correcting, pointing to the self-correcting mechanisms in science. And she talks a lot about the idea of these self-correcting mechanisms, but when it comes down to it, when she gets to the end of a chapter building up to this, in my mind, about what does self-correction in science look like? And she says, well, how do we know that science is self-correcting? The same way we know other empirical facts, we observe them. And so she says, when we observe scientists, we find that they have developed a variety of practices for vetting knowledge, for identifying problems and attempting to correct them. And to me, this feels pretty hand-wavy. I don't really know what she means by these mechanisms or processes. And she does talk a little bit in the book about peer review as an example, and I'll come back to that briefly, and that's something I think would be very interesting to talk about. How much does journal or grant peer review actually fulfill this function? But I think many scientists would agree that it doesn't really, it's not sufficient, that peer review isn't really meant to stop every error from making it into print. We need more self-correction than just what peer review can provide. Instead, what I think is a more realistic description of self-correction in science comes from James Heathers, who's trained as a psychologist. And I'm just going to quote one of his tweets here, where he describes, after many years of working to try to correct errors in the scientific record, he says, in reality, mechanisms to correct bad science are slow, unreliably enforced, capricious, run with only the barest nod towards formal policy, confer almost no reward, and sometimes punitive elements for a complainant who might use them. And a lot of this, I think, or imagine, is in reference to journals not being very good at responding to problems with their published work. And as editor-in-chief of a journal, editor at a handful of other journals before that, I have to agree. I think that our mechanisms at journals and at professional societies and so on are really slow, and we don't have a lot of formal policy. We don't have the resources. We don't have we haven't thought through what we should do when an error is pointed out and so on. So it's not exactly what I think the public might imagine the self-correcting mechanisms in science look like. When they say that science is really trustworthy, not because individual scientists are trustworthy, I think they're imagining that we really care about correcting errors, and when a potential error is identified, that there are really good processes in place for dealing with that and getting to the bottom of it. So one of the reasons that I'm convinced that we don't have great processes is partly because of the replication crisis that hit my field. So I'm in psychology, and more specifically in social and personality psychology, which was arguably in the eye of the storm of the replication crisis. So we had a lot of very public problems with replicability, with many, not just replicability, there were other problems, reproducibility, other validity issues in our published work. But this isn't just psychology, right? This spread or independently developed in other fields, looking at their replication results or other kinds of problems. In psychology, these are some of the kind of findings. This might not mean much to you if you're not in psychology, but some very classic findings that were in textbooks. Again, not all of these are irreplicable by any means, but some questions have been raised about many classic findings in psychology. So it's not just the most flashy, most cutting edge stuff, it's even stuff in the textbooks too. And some would say, well, yeah, great, this is self-correction right there. The fact that we're having this crisis, the fact that we're getting to the bottom of this, that's science self-correcting. We should pat ourselves on the back and be proud of this. And I'm not really comfortable with that. First of all, I don't think it should have gotten to a crisis stage. And I find it a little bit puzzling to use the problem itself as evidence that we don't have a problem. And my discomfort with this attitude kind of came to a head when I was on a committee of the National Academy of Sciences in the United States. It was a task force created to deal with the replicability and reproducibility problems in science and to write a report on the state of reproducibility and replicability in science. And in that report, there was an early chapter about error in science and whether error is normal in science. And one kind of the way I would summarize the theme of that chapter is captured pretty well in this quote from the chapter, which says, "The advent of new scientific knowledge that displaces or reframes previous knowledge should not be interpreted as weakness in science." And I agree with that to a large extent. I think that's more or less true. What I found frustrating and what I was hoping for from the committee was that we would grapple with the question of how much error is normal in science, what kinds of error are forgivable in normal science, and when does the pattern of errors become a reason for concern, a reason for worrying about the credibility of that field and thinking that maybe it's not so scientific. Because to me, if we say this and don't qualify, don't hold ourselves accountable at all for saying, okay, but we shouldn't be making the same errors over and over again, or some errors are such bad errors or so unforced that if a field is making those kinds of errors, that's a bad sign. If we don't add that, then we're just asking the public for a blank check for the freedom to make any kind of error over and over again, any pattern of errors. And I really wanted us to grapple with, and I don't know the answer to this question, but to grapple with the question of what is the difference between normal error in science and things not behaving as they should, a science that doesn't prioritize self-correction enough. This idea that, you know, the replication failures and other problems that have been pointed out are evidence of self-correction in science was also echoed in a very important chapter that came out kind of in the middle of the replication crisis in psychology by three very, very prominent psychologists. It was an annual review chapter in 2016, where they were talking about the replication crisis, and they said, all this is normal science, not crisis. A replication failure is not a scientific problem, it's an opportunity to find limiting conditions and contextual effects. Of course, studies don't always replicate. And again, some version of this is true, but not to any extent, right? We shouldn't be allowed to have failures to replicate all over the place as much as we want and still be able to say this is normal science. And one of the things I found frustrating was that some of the very same people who were later on in the replication crisis using the fact that we were dealing with these problems as evidence that we prioritize self-correction were also sometimes the same people or the same communities who had tried to stop that self-correction in the first place, who, when replication failures came out, called the replicators names or discouraged criticism and pointing out of errors. So this is just some of the names that the replicators and other kind of correctors and critics of psychology were called during this period. And, you know, some of these are kind of funny. I love accuracy fetishists. I would wear that proudly if it were me. And, you know, it's good to be able to laugh about it. But I think it's also important to remember these were very, very powerful people saying this about mostly early career people. And, you know, in some cases, very directly. So, for example, the human scum one, I can put it in context a little bit. It was, we don't know who said it. The reporter didn't identify the person who said it, but the reporter who wrote the story was somebody who came to the Society for the Improvement of Psychological Science conference and then was writing a story about it and interviewed somebody who was a critic of you know, the replication movement and so on in psychology. And then the reporter called me and said, you know, somebody you definitely know, a very famous psychologist, called you guys human scum. What do you have to say about that? And I was like, you know, what can you say about that? But then it made it in the story, an unattributed quote, but I have it on the journalist authority that it's a famous psychologist who said that. And there's no context here, right? There's no like, this specific action was a scummy action or something like that. So I find it frustrating, I think for reasons that are obvious, that then some of these same groups are turning around and saying, oh, look, these replications, the fact that we're doing replications, the fact that we have this open science movement and so on, shows how committed we are to self-correction. It feels a little bit to me like people who really want to insist that everything's fine, regardless of what the evidence and the critics show, they can incorporate that into their narrative of everything being fine. And we don't often see the rest of this cartoon, but it does not end well for the people who want to deny that there's any problem here. Okay, so I really like this sentence from the Don Campbell quote that organized distrust produces trustworthy reports. And I want to try to get into what is the role of organized distrust in self-correction and what is the role of open science in all of this. So in my view, there are two kind of fundamental pillars to self-correction in science. Science cannot be self-correcting without these two things. And the first is transparency, and the second is this idea of organized distrust. And the metaphor that I use when thinking about this is that transparency means that we're lifting the hood on the car. So let's say science is a car, we want to know if it has any problems. Well, we first need to be able to access all the stuff inside to see what's actually going on. But that's not enough. Just because the hood is openable, you can lift it, you could look inside in principle. That doesn't help if nobody's actually going in and testing things, measuring the levels of the fluids and so on, right? So transparency is good, it's absolutely necessary, but it's not enough. You need more than that. You need to actually use the transparency to go in and see if there are any problems and fix them. And I've used this metaphor in a paper where I borrowed from economics this idea of quality uncertainty, which was developed by George Akerlof. And he used the used car market as an example to illustrate this principle of what happens when there's information asymmetry between buyers and sellers. So I'm going to work out this metaphor in the case of science. So in the case of science, we have sellers selling their claims. So those are the authors of scientific papers. They want you to believe their claims. They're making an argument. And then we have buyers. Those could be anybody reading the papers or consuming the research. So other researchers, the public, policymakers, people in the field wanting to implement the findings and so on. When there's an information asymmetry between the sellers and the buyers, so sellers know a lot more about the product than they're willing to tell the buyers. So in the case of used car markets, if I'm trying to sell you a car, but I don't disclose a lot of information about the car's history, or in the case of science, I'm trying to sell you a scientific finding, but I don't lift the hood, I don't show you all the data, all the code, maybe I don't tell you about some of the studies I ran or some of the analyses I ran, then that leads to quality uncertainty on the part of buyers. They know that they lack information and they become unwilling to trust the market because they know that they don't have the information they need to assess the quality of different products. And he showed mathematically that this leads to a spiral, a decline in trust in the market altogether, and the bottom falls out. And so I think the same applies in the case of science. If we continue to ask people, say, trust me, and not being willing to show the information, show the inside, give the people, the readers, everything they would need to kind of reduce that asymmetry in information, then people are going to stop trusting us as much as they do. So transparency is absolutely key for trust in science, because being unwilling to be transparent, then that becomes a non-starter, right? We can't ask for trust if we're not willing to be transparent. I'm going to argue today that we're doing pretty well on transparency, at least in many of the sciences that have kind of taken up this open science movement. We still have a long way to go. I don't want us to kind of stop making progress, but I do want us to think about the other pillar as well. As we make progress on transparency, we need to remember what transparency is for. So let me first quickly make the case that we've made a great deal of progress in transparency. So I'm going to go through a couple of different kinds of transparency. I've tried to collect data. This is all from other people's research, not my own, from different fields. It's heavily psychology focused, but I did try to find data from other fields. So for example, in the case of open access to articles, preprints, being able to see papers without hitting a paywall, having to pay subscription and so on. The uptake of preprint servers across many different disciplines has been really fast, and this is already outdated at this point. So that's great. That's the kind of transparency, right? If you can't even read the paper, if people who don't have the resources, don't have the institutional subscription, et cetera, can't read the papers, then it's very hard to trust what's in them, to evaluate the quality. What about other open practices? So there was a survey, the State of Social Science survey, that surveyed researchers in 4 different fields. And this is self-report and it's retrospective. So I'd take it with a big grain of salt. But they asked the researchers, have you used any of these open science practices? They asked about 3 different practices. And if so, when was the first time you used them? And according to these retrospective self-reports, across the 4 social sciences, by 2017, when the survey was done, 73% of respondents had posted data at least once, and you could see that most of them had done so relatively recently for the first time. 44% had posted study instruments or materials, and 20% had pre-registered or done a pre-analysis plan. There's an update actually to this survey. The authors did a survey several years later, and they posted their data online. So you can see the rates several years later. But this is also somewhat borne out by behavioral data. So if you actually go and code what proportion of articles in different fields have a link to open data or open materials or pre-registration, you see quite a rapid increase. But again, not as high levels as here, but just quite a bit of change over time. This is data about open or transparent peer review. So this means posting the content of the peer review, not the names of the reviewers unless they choose to identify themselves, but transparent peer review just means that when a paper is published, the peer review history for that paper is published. So for example, Collabora practices this with every published paper, and more journals are adopting this practice of transparent peer review. Again, that's a kind of transparency that really helps us to calibrate our trust in a journal or in a particular finding. Does the journal put its papers through rigorous peer review? Did any issues come up in the review that weren't addressed in the paper, and so on? Disclosing contributions, so moving away from just naming authors to disclosing who contributed what to a paper. So there's a tool called Tenzing that helps researchers using the credit taxonomy disclose who did what. And this is really good for transparency, both because it helps give credit to the people for what they did, and also because it increases accountability. So if the problem comes up with the paper, it's easier to avoid this problem where everybody's pointing fingers at each other. I would argue that in addition to these kind of individual practices, we have quite good organizational structures around transparency and open science. And in fact, I didn't understand all of the language, but some of the stuff that Stefan talked about in the beginning, I think he mentioned several grassroots organizations, and there are also some kind of bigger and more formal institutions happening as well. So many of these are more grassroots, but some of them have become relatively stable, kind of top-down institutions by now. And this is just, again, this is very psychology heavy, and there's many more than this. But I would argue that we've started to organize. We've started to be from the grassroots, and very much led by early career researchers, started to create structures and institutions that really prioritize and promote transparency and open science. So I think we're making really good progress on transparency. And this is a pyramid that I borrowed from Brian Nosek, where he talks about for institutional and social change, you need to go through these steps in this pyramid. So first you need to make it possible for people to do something, then make it easy, then make it normative, expected, rewarding, and then only after that make it required. And I would argue that in many fields, I think the open science movement has hit this make it normative, make it rewarding stage of the pyramid, where the infrastructure is there, it's continuously being improved. It's great that there are so many people writing packages, improving templates for pre-registration, other things like that. That also helps make it easy, right? A lot of these things are getting debugged and improved to make them more user-friendly. And now we're at the stage where it's relatively okay to ask, oh, did you pre-register that? Or could I see your data? Or things like that. It's considered normative. And there's even some rewards like badges and awards, and some positions, tenure track positions, where they expect candidates to demonstrate their commitment to open science, for example. So it's a clear reward. Now, I'm going to switch gears a little bit, and I don't want to diminish the importance of transparency or the amount of work left to be done. I think this is really important. I think it's really good that there are still, workshops and many groups dedicated to transparency. And I think what I would urge is that we work hand in hand with transparency and organized distrust together to remember that the ultimate goal is to make science more self-correcting or more credible or more trustworthy. We can pick an umbrella term that is broad enough that it includes most people's core value in science. And that transparency is a piece of that, but it's not the only piece. And we need to make transparency work towards that bigger end. So this was articulated in a really short, really easy to read paper by Andrew Gelman called Honesty and Transparency Are Not Enough. And he says in that paper, consider the consequences for a researcher who eagerly accepts the message of ethical and practical values of sharing and openness, but does not learn about the importance of data quality. They could then just be driving very carefully into a brick wall, conducting transparent experiment after transparent experiment, and continuing to produce and publish noise. that's still better than running non-transparent experiment after non-transparent experiment, right? At least it's easier for the reader to tell that what they're producing is noise if it's transparently reported. But I think it points out that while transparency is absolutely good in and of itself, we also have to remember there are other goals, and that transparency can really become even more valuable when it helps enable those other goals. Okay. So what I'm going to argue now is that we're not doing so great on this other pillar of actually using transparency to detect and correct errors in science. And that's going to be much, much harder, right? As hard as it was to convince people to be more transparent, there was quite a bit of resistance, at least in my field of psychology. I don't know about other fields. There was a good deal of resistance, even just transparency. The resistance to criticism and correction is going to be even greater. And that's compounded by the fact that it's probably not why most of us got into science, right? Most of us probably initially got into science to make discoveries, not to find problems with other people's discoveries. It's not really a very appealing job for many people, but it's unfortunate that on top of it being something that not a lot of people want to do, that's hard to do, and that we need, we then kind of pile on disincentives on top of it by devaluing that kind of work. It's as if we all want to be able to go around and say that science is self-correcting, but we don't want other people to actually correct us or our friends. And this reminds me of another James Heathers quote from a tweet of his, where he said, "Science is self-correcting, sure, when we correct it, not because of magical progress." We need to think about, are there actually people in our field who do the work of correcting, and do we reward those people? Do we make it an attractive career path for people, an attractive thing for people to do? And yeah, like, who is doing it? And are we making sure that track is being rewarded? And so I mentioned that, there's an argument that peer review is where this kind of criticism happens. I have a popular article about my experiences as a journal editor and why I don't think that peer review really does its job. I also don't think it should be the job of peer review to just do quality control, right? It's going to be the case that we let things into the literature that have errors, even obvious errors. We're never going to get around that. We need more than just peer review. We need other mechanisms. We should improve peer review. We should make it a better quality control mechanism. And I think there's some really low-hanging fruit there that we could do to improve peer review of journals. But it's not enough right now. And even at its best, I don't think it would be enough to be the only self-correcting mechanism in science. Okay, so what might it look like to have a field that's really committed to self-correction, to identifying errors, correcting them, and so on? Well, that field would develop tools for identifying errors and make sure that they're rolled out, that people are using them. And luckily, we are already seeing some of this. So again, these tools are probably heavily psychology focused, but I think there's some version of them in many fields. That bottom one is stat check, sorry about that. And these are very, very heavily focused towards like analytic reproducibility and statistical errors. Obviously, there are many other kinds of errors, and in some ways, statistical errors are the least of our problems, right? They're relatively easy to detect. They're relatively black and white, but errors of measurement, errors of conceptualization, errors of causal inference, errors of generalization, those aren't black and white, but they're just as important, in some cases more important, I think, than statistical errors. So this is a case where we've kind of developed tools where it's easy to develop tools, but we haven't made much progress, I think, on how to do criticism and correction of more kind of conceptual errors. And obviously, we wouldn't be here without some post-publication organized distress. I don't mean to paint the field as having no commitment at all to criticism or correction. And, like some people have argued, the fact that we have replications at all, the fact that we have that we've made so much progress in open science and we can now do reproducibility checks because people share their data and code and so on, is some evidence that the beginnings of this are there, and we just need to build on it. So for example, there's all these replication projects. If you don't know, again, this is very psychology focused, but this is just to say that there have been quite a few large scale projects where dozens and dozens of researchers work together to try to replicate dozens of findings in the social sciences. The findings of them were not encouraging. So this is from a comic written in 2016, soon after the reproducibility project in psychology came out, finding somewhat dismal results for psychology. This is a cartoon of Alex Holcomb saying the idea that fewer than half of results that are published, many of which were heavily covered by the media, are actually true is very dismaying. And then this is me saying that seems problematic to me, which my lab has now made into a meme for our Slack, which is very useful. But at least we know this, right? That's something. It's much better to know that we have a replicability problem than to have no idea. With reproducibility, same thing. Tom Hardwick has done some great work attempting to computationally reproduce the results of papers where the data and code are open. So this is where the authors already knew they were publishing in a journal where they would be required to post their data. And so these are probably data that are more reproducible, results that are more reproducible than your typical article, because the authors voluntarily chose to publish in a journal and where they would have to share their data. Tom was able to reproduce about a third of the article, all the results in the article without any help from the authors, another third after getting help from the authors, but there was more than a third where they were not able to reproduce every single result in the paper, even with help from the authors. Now, maybe reproducing every single statistic in the paper shouldn't be the goal, but again, this is a set of papers that surely look better in reproducibility than your typical papers. We also have things like registered reports where authors can submit their work before they collect data and they can get feedback. So this is a really good kind of criticism where it's useful before you run the study. You can actually change the design of the study to address a confound or another threat to causal inference that a reviewer identified, or maybe someone suggests a better measure, a better way of operationalizing one of your variables. So this is really, really useful and good criticism. And it's becoming more popular. More and more journals are offering this option for manuscripts. It also provides an opportunity to do another kind of criticism, which is kind of a forensic approach, looking at the published literature and trying to figure out there's no really good way to estimate the proportion of, for example, p-hacking or questionable research practices. But registered reports provide kind of a control group to see how does the traditional literature, where authors submit their work after they've completed the work, compared to the registered report literature where the sources of bias are reduced because the authors and the reviewers and editor together come up with an agreement of what's going to be done, and the authors have to follow through with that, and the editor checks that they follow through with that. So there's less opportunity for flexibility on the part of the authors. There's less opportunity for bias on the part of the editors because they can't reject the paper if the authors follow the plan. So even if the results come out non-significant or not supporting the theory, it should get published anyway if everyone follows the rules. So we can compare the literature, the small number of articles that have been through this process of registered reports, to the traditional literature and ask, do they look similar? And if they look very different, then that would be a sign that maybe there's a problem. Maybe the traditional literature has quite a bit of bias. And indeed, there have been two analyses doing this, comparing the traditional literature to the registered reports literature, specifically on the factor of what proportion of published results are null results or negative results. In the traditional literature, it's between 5 and 20%, depending on the field. In psychology, it's closer to 5%. So the vast, vast majority of published results in psychology, the key result is significant or positive. Whereas in the registered reports literature, it's about half and half, or more than half of published registered reports, the key result is a null result, a non-significant result. Another analysis focusing just on psychology found the same thing. In the traditional literature, 95% of results are significant. In the registered reports literature, less than half. So there are a lot of possible explanations for this. Not all of them are bad. But I think the most parsimonious explanation is that at least some of this difference is due to bias in the traditional literature. So there are some bits and pieces of criticism and correction and some efforts towards more criticism and criticism at a time when it's actually more useful and something can still be done about it. But I would argue that what we have right now is pretty disorganized distrust. We do have some skepticism, some questioning and verification, some actually going in under the hood and checking things, but it's not nearly as organized and as rewarded as the transparency progress that we've made. So I think this is a problem, and it's especially a problem because so much of this work, like the open science movement, is led by early career researchers. Sorry, my dog is making noises in the background. I apologize if you can hear him. So what would it look like to move in the direction of more organized distrust? So I think right now we're at this stage of the pyramid where criticism is possible. And if you identify an error, it's possible to point it out and to get it corrected. It is not easy. It's certainly not normative, absolutely not rewarding, and by no means required. So how can we encourage more organized distrust? Well, I think we need to encourage more distrust, and we also need to encourage more organization, make it more of a formal, structured thing that's rewarded. So I'll talk about, at this point in my talk, it's even more kind of speculative and more into just ideas I've been kicking around. I'm curious to get thoughts on. I'll talk about a little bit what I think that organized distrust would look like. And in the case of cars, you know, with the used car market, what happened when this problem of quality uncertainty and information asymmetry started to erode trust in the used car market is third parties came in who could verify the history of the car, for example, whether it had been in accidents, and also the state of the engine and other things, right? So you bring in mechanics or you bring in experts who are neutral third parties who assess the situation and give the buyer the information that the seller wasn't willing to give. And I think that in psychology, we could have the same thing. We could have a role for people who are expert and relatively neutral in terms of their own interests in the theory or the finding, who could come in and assess and do stress tests and measure the fluids and so on. And it wouldn't always be criticism, right? Sometimes it would be giving a really good health check and say, we tested the robustness of this, we poked and prodded it, and it came out looking really good. So this gets kind of a negative tone, but it also improves the credibility of work that should have high credibility, right? It's a way for trust to be calibrated to how good the work actually is. So in psychology, one of the big developments of the open science movement was something called the Psychological Science Accelerator, which is a great initiative. It's focused on doing really large scale studies that are much more globally representative than the typical psychology study. And actually Accelerator is in the name, I think, because it was inspired in part by particle accelerators in physics, but I'm going to riff off of that name and take this metaphor a little bit too far. So let's say that that science is like a car. We want to make sure it's a well-oiled machine, and we want it to race as fast as possible, right? And things like this, like Science Accelerator, but many other things, a lot of just generally large group, large scale science, they're making things possible that weren't possible before. They're allowing us to move not just at a speed that wasn't possible before, but also a scope and a range and ask questions that we couldn't answer before. And that's great. But with high speed come crashes and other problems, right? So if we're going to accelerate things and we're going to make things go faster and harder and bigger, and oops, how do I get out? Then I would argue we also need something like a psychological science garage, that every field should have a dedicated community, not just one team or one group, but communities of experts who you take a finding to or a claim or output, and if you want to know how much can we really trust this, especially before we roll it out into public policy or build a lot of theory off of it or things like that, right? It might not be that every finding needs to be taken to the garage, but ones that we have a reason to worry about, or ones that we're going to put we're going to lean on very heavily for the public or for within our scientific field. So you could imagine that a garage like this would use the tools that exist and develop new tools for stress testing findings and giving health checks and reports of how robust, how reliable and valid findings are. And of course, the answer wouldn't be a single number, right? A finding could be absolutely statistically robust, but we're not sure about the causal inference. Or it could be really solid for what it is, but we don't know if it would generalize, right? And there are examples of this. For example, NASA in the US has, different levels of confidence that they move up as they move closer and closer to application in very, very high stakes settings. So we could imagine this is a kind of escalating thing where as the stakes get higher, we submit it to more and more tests and have more and more dimensions that get explored. And it could be modular. So it could be that for some findings, we just are interested in one dimension of how robust it is. There are some examples of this kind of in isolated cases for short terms or narrow scope. So one is the SCORE project, which was funded by the US Defense Department, DARPA. And as Stefan mentioned, I was part of one of the teams in that project, the Replicats team. And so there we stress tested hundreds or thousands of findings, trying to kind of pick and poke at them and figure out which ones are more trustworthy, which ones are more replicable, reproducible, generalizable, and just valid in general. And the project is still ongoing. There's some results out from that, but they focus on social sciences. Another example was an initiative that started by a group of researchers, I think mostly based in the Netherlands, where you could sign up to be an expert who would be willing to test other people's work, try to find errors, etc. Or you could pay those experts, you could be a consumer and ask for experts to find problems in your work. So for example, you could maybe have a study design that you're ready to implement, but you want someone outside your research team who's maybe has a different perspective to kind of look at it and critique it. Or maybe it's just your code, you want someone to debug your code, things like that. One researcher, Nicholas Coles, used this red team market and put a bounty on his own research, said, I'll pay anyone who finds a problem with my work. So unfortunately, from what I hear, red team market is no longer functioning, or it will be defunct soon, which is not too surprising to me. I don't think it's something that is popular enough yet, but we need to work to make it popular. We need to make it so that people are willing to pay and see value in saying, yes, find the problems in my work. And also the people who do that, their research should be trusted a lot more, right? If something had a badge of like, this was tested by this outside third-party expert or expert team with a lot of different expertise, and it came out looking good, then we would trust that even more. In my lab, we've also been working on a kind of big critique project focusing on the social and personality psychology literature. So this next slide is a slide about our project. You have to know one thing about social and personality psychology, which is that all of our acronyms have a lot of S's and P's in them because social psychology, personality, etc. So our project is called Surveying the Past and Present State of Published Studies in Social and Personality Psychology, where we, and Sarah Schiavone is the lead on this project, we measured as many things as we could about 8,000 different articles published in social and personality psychology between 2010 to 2020. One of the central aims is to see if anything changed in that decade. So that was the decade of intense crisis and reform movement in our field. But this is still just one team doing just what we can. It's relatively narrow. It's going to have many, many limitations. And it can't be just up to individual researchers and labs to do these little tiny projects. We need more organization. Okay, so if we had things like a psychological science garage, what would this look like? And I think the distributed, which is a tagline from the Psych Science Accelerator, but I think this is really important because it needs to not just be one individual person or group and their own biases and their expertise, right? But just like with mechanics, you could have different mechanics, you could get a second opinion. We would have several of these, hopefully many of these in every field with different priorities, different values, different areas of expertise. So one garage or one group might give a finding a really high mark or high marks on some dimensions. Another group might say, no, we think it's really crappy on those dimensions, but it's strong in these other ways, etc. There's no one right answer, but it would further the conversation. So would anybody want to do this? If this was a career track, would we have anybody doing it? I think there's a couple of reasons to think that there might be some people interested in doing this. So one is that there's people with specialized training already, quantitative researchers, experts, statisticians, methodologists, etc. So right now, a lot of methodologists, at least in my field, spend a lot of time working on the very, very cutting edge, developing the next step in a particular statistical technique. Why not also encourage people who want to join the field to become experts in methods and statistics and design and so on, but not necessarily to do something that pushes the boundaries of knowledge, but that improves the tools that everyone is using all the time, right? There are a lot of errors that get made repeatedly over and over again. As a journal editor, I see, for example, with mediation analysis, very, very common basic errors. And it's great that people are pushing the boundaries of mediation analysis, but we should also want to hire and reward people who help make the way that mediation analysis is used hundreds of times every day more solid and more valid. Some people have the right personality for this kind of job. Many people who get into science like solving puzzles, and one kind of puzzle to solve, and in fact, one of the reasons I love journal editing is I do really like reading other people's work and trying to figure out if I can see any holes in it, if it all makes sense, if I come at it from different angles, do I think about it differently, and so on. So some of us at least like reading other people's work and working on other people's work. And I think one advantage of a specialized career track is the impartiality. I also think it's quite embarrassing that we don't have something like this, because many corporations who are not primarily interested in accuracy and truth, who are primarily interested in profit, but nevertheless recognize the value of accuracy and truth for making a profit, and they have red teams within their organization. So it's kind of hard to answer the question, why don't academic institutions have things like this, or scientific professional societies and disciplines? Felipe Romero is a philosopher of science who's actually written a whole article arguing specifically for independent kind of career track or role for replicators in particular, but I think all of his arguments, or most of them, generalize to other kinds of criticism and correction work, not just replications. I'm going to skip over this and go a little bit quickly, but I want to make one point, which is that when we talk about having a community of critics, and this is true of a community of scientists too, diversity becomes really, really important. And Naomi Oreskes made this point, and she was describing Helen Longino's work, a philosopher of science, who talked about the importance of diversity for the social processes of self-correction in science. And Naomi Oreskes writes that the greater the diversity of a community, the greater the degree of objectivity it may be able to achieve as individual biases and background assumptions are outed. And I think this is really easy to understand if you imagine, for example, that you're submitting a registered report and you're going to get critiques of your work that helps you design a better study before you run it. Or maybe you pay a red team market group of researchers to critique your work. Would you rather have a group of critics who all have the same biases, all have the same training from the same lab or the same kind of camp in your field, who have the same theoretical commitments, the same personal experiences in their lives that lead to the same blind spots? Or would you rather have a group of critics with different blind spots, different biases from each other, right? I think we would all much rather have feedback and criticism from people who have kind of blind spots and biases that don't overlap, so that they can see the things that the other critics can't see. So it becomes, I mean, it's already important just in any scientific community, but in a community of critics, I think it becomes really important that we make sure that any blind spots, which are necessarily going to exist, are kind of covered by other people within the community. So I've made a slide of, again, very psychology focused, but this is what the people I know who are most involved in reform in psychology look like. I think, you know, obviously there's only some aspects of diversity that you can judge from photos, and the point isn't really what they look like. But one thing that would jump out at you if you're familiar with psychology is that these are almost all very, very early career researchers. And many of them have been doing this for years already. When I started, they were extremely early career. And this is just to say, I think there are a lot of people out there who have excellent training, who are excellent at spotting errors and at making other people's work better, and who would love a job in academic research. So several of these people have already left academia. In some cases, that was what they wanted, and that's great. In some cases, I don't think it was what they wanted. And if there were career tracks of jobs for people who are as good as they are and interested in this kind of role, I think that we could have kept some of them in academic research. In Felipe Romero's paper, he talks about how we would implement a professional career track for replicators, or more generally, I would argue, for critics. And he talks about the role of different kind of institutions in making this a reality. So he talks about what universities and departments can do. They can create positions specifically for confirmation research, is what he calls it, replication. But again, I would expand it to also just checking many aspects and critiquing many aspects of the quality of published work, and tailor promotion guidelines for those positions. Funders could allocate funding for that kind of work. Editors could publish those kinds of critiques and results from replications and so on as independent papers, contributions. Professional societies also have an important role to play in rewarding this kind of work. Okay, so I talked earlier about what the transparency landscape looks like, with many organizations, some becoming quite powerful, having funding behind them and so on. And in contrast, what I think the organized distress situation looks like in psychology, and I suspect it wouldn't look all that different in many other fields. And we see quite a stark difference, and I've exaggerated a bit here, but, and you know, also many of the people on the right are also the people who were behind creating the institutions on the left. So we know that we can get from very grassroots to more organized. It's possible to get there from here, but we really need to be deliberate and think about what that looks like. Maybe positions created specifically for teams of experts that go in and critique things is one thing that might look like. That's something I've been thinking about. But I think more generally, every field should challenge itself to think about what makes them scientific. If they appeal to something like self-correction, that they're trustworthy because of the commitment to self-correction, then the next is, what does that commitment look like? Where are we investing so that we catch and correct errors in our field? And if we can point to those things and point to not just individuals, but organizations doing it, and money going into those kinds of positions, other kinds of rewards, recognition, and so on, going for that kind of work, then that's a sign of a really healthy field, in my opinion. And I'll leave it there. Thank you.